Okay, guys, welcome. My name is Prince, and today I will be presenting a topic on electrical protection system for feeder and branch circuits. All right. So the National Electrical Code will be utilizing for explanation regarding protection, and we'll be going through proper sizing and determine the types for electrical protection for conductors and electrical circuits and feeder, right? And we'll be pointing out the proper location where protection devices is incorporated. All right, so this presentation was brought to you by the Visual Society of Engineers. All right, so when it comes to defining overcurrent protection system, all right, so a system for protection against overcurrent is such required to prevent conductor and equipment from reaching a temperature which is considered hazardous or dangerous. All right, so overcurrent protection device is a device that interrupts current in its current limited range and is creating that protection that is needed. All right, so figure 1 illustrates what this device is, right? Now, what are we protecting? Electrical protection system shall protect conductor and equipment against the following conditions, such as high ground fault, short circuit, burn down, and fire. When it comes to the system for which we are protecting, we look at conditions of ground faults. All right, ground fault occur between live conductor and electrical ground. The ground could be metallic surface, it could be exposed grounded surface. All right, and short circuits occur when there's a breakdown of electrical insulation on the electrical conductor, right? So when you have one conductor creating contact with another conductor, and touching, it creates a shortage. So the path for which the current would normally flow would be diverted, all right? And burn down is what would cause by a short circuit situation as well, where the circuit basically would go up into fire due to the electrical hazard that is being presented. All right. So protection system is designed against conductor leading to fire or burn down. Feeder and top protection. Now, Article 240.4 requires conductor to be protected against overcurrent according to their ampacity, and required they are protected at the point at which they receive their supply. So every conductor requires protection at the point at which it receives supply. So normally the feeder conductor would be significantly larger than the top conductor. Feeder, for example, is a conductor coming from our main service, and it goes to the main circuit breaker. Then you have a top conductor that is taken off that feeder conductor. All right? Sometimes we may have disconnect situation coming from a feeder going to various breaker, or going out into the distribution network. All right, so the ampacity of the top conductor cannot rather be less than 1/10 of the rating of the main device or the feeder protection. Now, when we look at the feeder conductor, right, we're going to look at the conductor in this figure, say 500 kcml, and we're tapping off this 500. So those conductors respectively would have been 200 amps, 150 amps, 300 or say 30 amps. Now, based on the rules that is outlined, the maximum or the minimum size of any other conductor should be at least 1/10 of the main feeder that is coming in. Now, protection of conductors. Conductor other than flexible cords, flexible cable, fixture wires shall be protected against overcurrent in accordance with their ampacity specified in Article 310.15 unless otherwise permitted by 240.4 in the National Electrical Code. The rules for governing conductor protection is required by Article 240.4 is listed below. Now, overcurrent protection shall not require where interruptions of the circuit leads to an hazard. Example, a magnetic pole lifter or a fire pump circuit. Now, when we look at a magnetic pole lifter, we're talking about equipment that is lifting maybe a container or metal in particular. If by chance the power lift goes off the supply, that which it's lifting will fall to the ground. Right? In most cases, we can't afford that to happen. Therefore, we have to maintain constant power supply to our power lift. All right? So, what does that mean? That we have to ensure that there's no interruptions of the supply by means of any protection mechanism. So even if we have a ground fault situation, we should never have that magnetic pole lift been released at any point in time due to a hazard that may present. Fire pump circuit is a next circuit that we have to protect against disruption in terms of power. Because once a fire is started, which we'll never know, the fire pump should have available power to deal with the fire that is present. Now, the next highest standard overcurrent protection device shall use when selecting protection for circuit 800 ampere or less. The ampacity of the conductor that is protected shall be equal to or greater than the rating of the overcurrent device, 800 ampere or greater. All right. Now, let's back up a little bit. I'm going to talk about the next higher overcurrent protection selecting for 800 ampere or less. All right. Now, these rules require that when the conductor or the ampacity rating for the conductor that is selected is less than 800 amps, we may have a situation where we're going to choose an overcurrent protection device that is a little higher. All right. So the next higher standard rating shall be selected for any conductor less than 800 ampere. All right. Now, when the conductor that is being protected is 800 ampere or greater, then the protection requires that the breaker or electrical overcurrent protection device shall not be less than the ampere rating, right, of the conductor. So the conductor shall be greater than the overcurrent protection device or equal. All right, so that is only the variation in this rule. All right, so the overcurrent protection shall not require where interruptions of the circuit may lead to an hazard, such as a magnetic pole lift, and the next higher standard overcurrent protection device shall use when selecting protection for circuit 800 ampere or less, right? And finally, the ampacity of the conductor that is protected by or shall be equal to or greater than the rating of overcurrent protection device 800 ampere or greater. Now, the final rules, right, protecting conductor against overcurrent protection. When we talk about conductor in the range of 18 AWG copper, 16 AWG copper, 14 AWG copper, 12, 10 AWG copper, or aluminum copper clad. Figure 4, right, is an illustration of such conductor that we used at this requirement, right? Now, for this rule rather, we require small conductor to protect it at their capacity. So there should not be any protection device at a value greater than the size of the conductor, right? So if the conductor has an ampacity of 20, 30 amps, then the protection device should be rated 20 or 30 amps, all right? So the conductor should be protected at a rating, right? So this only applies for conductor in the range of 18 AWG, 16 AWG, 14 AWG, 12, 10 AWG, copper or aluminum, and in some case, copper clad, all right? Now, secondary conductor of transformer must be protected by an overcurrent protection device when it is either of these units identified. Now, for single-phase transformer, other than two-wire type, a multi-phase connected transformer other than delta type, all right, so what this is really saying is that the overcurrent protection device should be placed on the secondary of these type of transformer, all right? So you have your incoming supply for your primary and the transformer, and on the secondary, you should have your protection, all right? And this goes for single-phase transformer or multi-phase connected transformer. Now, transformer should be protected by the primary if and only if it complies with those mentioned here. So first, you should have a two-wire primary and a two-wire secondary, all right? And 3-phase delta and 3-wire connected single voltage. Now, when we talk about protection for transformer on the primary side, it only applies for, standard 2-wire primary, secondary transformer. So you will have your incoming supply on the same side where your protection is located. And it applies for delta system, right? Where it's 3-wire connected, right? So you'll have the protection, your primary, when there's a delta system, a 2-wire primary, all right? So just bear that in mind. So if you can take a little back so you can understand what I'm talking about, right? So for the secondary protection, you need a single phase transformer, a multi-phase transformer, right? This is not the 2-wire type, not the delta type, right? And for primary protection, you need a delta or the 2-wire primary and 2-wire secondary types transformer, right? So primary protection versus secondary protection, right? And the type of transformer that we're going to utilize for the location of our overcurrent protection devices. Right? So fuse and circuit breaker, the standard rating for fuse and inverse time circuit breaker shall determine using Article 240.6. Fuse and trip circuit breaker uses standard rating for fuse and circuit breaker. Right? So the fuse and the circuit breaker standard rating can be found in 240, right? 0.6, right? The standard rating is manufactured and it is listed according to the code or the National Electrical Code. Right, so again, we found in the code book where you can see the rating of overcurrent protection devices and fuels that are available on the market. Right? So the next thing we're going to look at is adjustable trip circuit breaker. Now, adjustable trip circuit breaker, ampere rating settings shall have adjustable means for adjusting the current setting or equal to the max setting possible. All right? Now, restricted access adjustable trip circuit breaker. A circuit that have restricted access shall be equal to the max adjusted setting, example, a bolted equipment enclosure or lock door or removable cover. All right? So where we're not able to access the circuit breaker, we should establish a max adjusted setting. All right? So can you imagine you have a panel, you're unable to get to it. Then you must have the breaker adjusted to the value that is supposed to protect the circuit. All right? So adjustable trip circuit breaker should be adjusted to the value for protecting the circuit, right? And where there's restricted access, there should be the adjustment for the breaker to actually allow maximum protection for the circuit, right? So lock door, bolted equipment enclosure, and equipment having removable cover should have the right adjustment setting for the adjustable trip circuit breaker. Thermal overload protection. Thermal device shall not be used for protection of conductor against overcurrent due to short circuit or ground fault. all right? But use of such device permitted to protect motor circuit against overload condition. So what they're saying is that we use the protection device for what it designs for, all right? So ground fault protection of equipment shall be provided for solid connected Y electric service 150 to ground. And it is designed to protect line to ground fault on the load side of the service disconnect. All right? So for ground fault protection, we have to have it designed for the Y connected system, otherwise called star connected system. Normally, each phase is designed for 150 volts to ground, right? And it is so designed to protect on the load side of the service disconnect. Current limited overcurrent protection device is one that cut off fault current and short circuit from building up to their full available value. All right, so we're looking at a variation of the protection devices. Look at thermal protection, which is connected in series with conductor, only designed to detect high temperature in the conductor. All right, as the name suggests. We have ground fault protection, which is protecting line to ground, right? And is designed to connect on the load side of disconnect means. And current limited overcurrent protection device, which is our standard overcurrent protection device, is designed to protect against short circuit and fault current. All right. And here we have a diagram which is illustrated the kind of protection device that is available. All right. And how it is actually incorporated to protect General Motor and so forth. All right. So incoming supply is protected by the disconnect means, and that is incorporated with fuse, built and designed with fuse protection. And you have a contactor which received the power from the disconnect means and overload protected device, right? All right, now protection device, though it has the purpose of protecting conductors, it must be so arranged in a way that prevents haphazard situation. So overcurrent protection device should be selectively coordinated, which means you want to put the protection where it's deemed necessary. All right? So you need protections at the closest point where a particle load is located. All right? So one of the things we bear in mind when we are setting up distributed power system, that each branch is protected by an overcurrent protection. All right? So what if we had only one protection for the entire system? Then any fault on, say, the lower branch, it requires a fault on the upper branch. So, for example, we have fault downstream, you're going to come right upstream. So we have to selectively place our breaker and protection device in various locations so as to prevent a cascade of all the circuits open opening or rather breaking down, right? But say once we have the protection in the right and the proper area, then we can assume that the conductor downstream is not going to be affected by the conductor upstream. All right? So once the faults occur in any one of the conductors of the branch circuit or the distributed system, then if there's a fault occur at any point on the circuit, the breaker that is closest to that fault is going to be activated. So all the circuit remain active, all right? And that bad portion that is affected is going to be isolated. All right, so guys, thank you for taking in this presentation, and we'd like you to go to our online engineering platform at thevigilance.societyengineers.com for more information. All right, so don't forget to give us a like, subscribe, and hit that notification bell so you can continue to get more presentation like this. All right, thank you for listening, and have a good day, and we will see you again. Take care.